Hi, welcome to Mrs. Park's Geometry class. This is Chapter 2, Section 7, Proving Segment Relationships. So last video was kind of tough. It was long. I'm sorry about that. But we made it, so we're going to move on to Section 7. Alright, why? Emma works at a fabric store after school. She measures the length of fabric by holding the straight edge of the fabric against a yardstick. Like she's doing here, she's holding it straight on a yardstick. To measure length such as 39 inches, which is longer than a yardstick, she marks a length of 36 inches. From the end of the mark, she measures an additional length of 3 inches. This ensures that the total length of fabric is 36 plus 3, or 39 inches. Okay. So ruler postulate. So it's actually called a ruler postulate. So if you have a ruler, okay, the points on any line or line segment can be put into one-to-one correspondence with real numbers. So example, given any 2 points, A and B on a line, if A corresponds to 0, then B corresponds to the positive real number. Okay, 3. That's all it is. So it's really like how you would actually use a ruler. You put a 0 mark in the first point, and then the next point will be how long the length is. It says they gave it a name, a ruler postulate. All right, segment addition postulate. Okay, so this sounds fancy, but it's really, a segment is a line, like it has 2 endpoints, right? If you add it, it's going to equal the whole length. So if you have AB and you add BC, okay, then the total is AC. Okay, AB plus the BC will equal the whole length AC. Alright, so when will we use this? Alright, here is another 2-column proof. You're like, I know you're saying, oh, another 2-column proof, we just got over it. But as I told you before, 2-column proofs, we're going to be using this throughout the year, the entire year. So just get used to it, guys. I'm sorry, but we'll have to do it. Alright, so here is example 1. Prove that segment CE, okay, CE here, is congruent to segment, what is that, FE? FE, okay. So those 2 lines are congruent, and ED is congruent to EG. So actually, let me use better symbols here. Alright, so CE is congruent to FE, okay, and ED is congruent to EG. Then CD is congruent to FG. Okay, so that's what we're trying to prove. Alright, so given is everything before then. If. Okay, so all this is given. Then part is what we're trying to prove. Okay, so given, write down what's given and write given. Alright, second part, okay, definition of congruence. If the line segments are congruent, then the CE is congruent to FE. Line segment DE is congruent to line segment EG. That means ED is congruent to EG. Okay, so that's definition of congruence. Now, CE plus ED equals CD. So that's the addition postulate, congruence postulate. So CE plus the ED is going to equal CD, is what they're saying. Okay. So with that, okay, I'm going to substitute. Instead of CE, I'm going to put FE. Instead of ED, I'm going to put EG. Okay, I substituted. Okay. Now, from there, EG plus EG, I'm sorry, FE plus EG equals CD. Okay. So, and then here you have FE plus EG equals, FE plus EG equals FG. Again, that's the addition postulate. And then CD equals FG. So that is substitution. So we did this in one set and this for the other set. Okay. Now, wait. No, I'm sorry. I'm getting myself confused. They weren't set. Oh, sorry. Okay. Let me back up for a bit. Okay. Alright, so we got to here. Okay, so segment addition postulate. FE plus EG equals FG. So FE plus EG equals F. So if you add this part and the second part, it's going to equal the whole entire part. Okay, good. Now you have those two that are equal. So you're saying this part is same as CD, and this is also equal to FG. So these two are the same. FEEG, FPEG. Now we can say CD is equal to FG by using substitution. Now we're going to go back and say we need to prove this, right? So it looks the same, but now we're going to do congruence and their set line segments. So definition of congruence, and that's how we prove that line segment CD is congruent to line segment FG. Alright. Ooh, that was hard. Move on. Move on. Move on. There we go. Alright, so here's your turn. You got the easy part. You're gonna just fill in, okay, what does B go, what is C, what is D, and what is F, okay? So B, C, D, F. Tell me what should go in there. C has two parts. Okay, there's this part, and then there's this part, okay? So you have 1, 2, 3, 4, 5 answers to give me, all right? And come back when you're done. Alright, segment congruence. In lesson 2.6, you saw that segment measures are reflective, symmetric, and transitive. Since segments with the same measure are congruent, congruence of segments is also reflective, symmetric, and transitive. Properties of segment congruence. So if you have segment AB is congruent to segment AB. So it's the same thing we did with the previous section, reflective, symmetric, and transitive, but now we're using segments, okay? Segment AB is congruent to segment CD, then segment CD is congruent to segment AB. Symmetric, okay? Transitive is transfers. Segment AB is congruent to CD. If CD is congruent to EF, then AB is congruent to EF. Alright, transitive property of congruence. Okay, so given AB is congruent to CD, okay, so these two are congruent, and CD is congruent to EF, okay, so that means AB is congruent to EF. Okay, paragraph proof. Since segment AB is congruent to segment CD, and segment CD is congruent to segment EF, AB equals CD and CD equals EF by the definition of congruent segments by the transitive property equality. So that's the important part here, that you're using the transitive property of equality. AB equals EF. Thus, segment AB is congruent to segment EF by the definition of congruence. Alright, proof using segment congruence. Volunteering. So according to a recent poll, 70% of teens who volunteer began doing so before age 12. Good for you guys, teenagers. Others said they would volunteer if given more opportunities to do so. So we just need to give you a chance, huh? Alright, well, volunteer. The route for a charity fitness run is shown. Checkpoints X, Z are the midpoints between the starting line, and checkpoint Y and checkpoint Y and the finish line F respectively. If checkpoint Y is the same distance for checkpoint Z and X and Z, prove that the route from checkpoint Z to the finish line is congruent to the route from the starting line to checkpoint Z. Yikes. Okay, so what's given? From all this, you have to be able to write this out. Okay, given is X is the checkpoint for the midpoint of SY, and Z is the midpoint of YF. We need to prove, and XY is congruent to YZ. We need to prove that ZF is congruent to SX. Okay. Alright, so here is the two-column proof. Alright, so we write the given. That's the easy part. We need to prove this. Okay. So segment SX is congruent to XY, and segment YZ is congruent to ZF, definition of midpoint. And then you have the blue equals the green, definition of congruence. Then we're going to do a transitive property. If this is that and that is this, wait, and then this is that. Okay, so transitive property, so you have now X, Z, Z, S, X is congruent to Y, Z. Right, and S, X is congruent to Z, F. Therefore, you have ZF is congruent to SX. Okay, symmetry property of congruence. We just flipped it over. Okay, I'm going to give you a minute to look at that. Or you can pause the video. Alright, so here's your turn, number 2, carpentry. So go ahead and try number 2. And when you're done with the homework. But if you're having trouble with this, I know 2-column proofs are hard, but we'll just have to practice more in class. Alright, so when you're done with homework. Thanks for watching.